this lesson we are going to begin looking at solving some different inequalities. We're going to start with just one variable ones that can be switched to a number line. So inequalities are those things that have the greater than or less than symbols symbols in them. You're going to do this just like if there was an equal sign in there. The only thing you do different is you have to switch the direction of the inequality, or the direction that the arrow is pointing, when you either multiply or divide by a negative. Okay? So I think it'll make sense as we kind of move through this. So here's the first one. Negative 2x plus 14 is less than 26. So if this was an equal sign, in order to solve for this, you would subtract 14. Okay, I do not need to switch the direction of the inequality because I did not multiply or divide by a negative. So I don't need to worry about that. Okay, so when I subtract 14, 26 minus 14, we know is 12. Okay, bring down the negative 2x. And now to solve for x, I would need to divide by negative 2. And now, because I divided by negative 2, again, when you multiply or divide by a negative, you need to switch the direction of the inequality. So that's what I did here. And I just get x is greater than, and then 12 divided by negative 2 would be negative 6. So this is what it would look like in your solution. Okay. And then I am going to first of all plot this on a number line for you. Okay. So on a number line, when I do this, x is greater than negative 6. I'm just going to put a few spots here on a number line, and I'm just going to go negative 9, negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative, just a few spots, just so that you kind of know. Okay? So on a number line, when you graph this, if this symbol right here is not underlined, that means that the number has to be greater than negative 6. It can't include exactly negative 6. It has to be greater than negative 6. So it could be negative 5.999999999. It cannot be exactly negative 6. In order for it to be exactly negative 6, it would need to be underlined. But because it can't be exactly negative 6, I'm going to make an open circle at negative 6. Okay? Then again, my solution looked like that. X was greater than negative 6. So that's how you would read this. I need to shade all the numbers that are bigger than negative 6. That's what that's telling me to do. Shade all the numbers that are bigger than negative 6. So in order to shade all the numbers that are bigger than negative 6, I'm going to go this direction from negative 6. Okay, these are the numbers that are bigger than negative 6. Negative 5 is bigger than negative 6. Negative 4 is bigger than negative 6. I know it doesn't seem like it, but if you're only $5 in the hole, you have more money than if you're $6 in the hole. So think about it like that. Okay? So that's what it would look like on a number line. Then, this is probably new to you, but we are going to put this solution in both set notation and interval notation. Okay? In set notation, this is what you do. You make one of these funky little brackets, and you always start off with x and that line. And x in the line, this is how you read that. The set of all x such that, and now all you have to do is copy this for me, okay? X is greater than negative 6, and then close your bracket. Okay, that's all you have to do. In interval notation, you need to tell me where it's shaded. Okay, so in interval notation, I start shading right here. Okay, this is where I start shading. Notice though I have an open circle at negative 6. And because I have an open circle at negative 6, I am going to do a parentheses here at negative 6. Had that circle been colored in, and it wasn't, but had it been on a number line and it was colored in at negative 6 like that, then when I did my interval notation, I would start with a bracket that said negative 6. Okay? So, just so you know. But I am shading now from right here, which is not quite negative 6. So that's why I have the parentheses. Open circle means you have the parentheses. Then I have shaded to the right, and I continue to shade to the right, to the right, to the right, to the right, to the right. As far as this goes, this shading goes on forever and ever and ever. It will never end. So it goes all the way, so I put a comma, all the way to positive. That symbol means infinity. And whenever you're using positive or negative infinity, you close it with a parentheses because you can never reach positive infinity or negative infinity. There is always a number that is bigger or smaller than it. You never get to that exact destination, and so you close it with a parentheses. Okay? We'll do a couple more here, so hopefully this will be okay. All right, here's another one. Again, I'm going to solve this. Just as if there was an equal sign in there, except for if I add and subtract by, or multiply or divide by a negative, I have to switch the direction of the inequality. So I will subtract 2 here. And then I have 3/4 x is less than or equal to 9. And oh my goodness, I have a fraction. Ah, I know, you guys will freak out, some of you. Dividing by a fraction, remember, is the same as multiplying by the reciprocal. So I can either think of dividing by 3/4 or multiplying by 4/3 on both sides. So that goes like that. I did not multiply or divide by a negative number, so because I didn't multiply by a negative, I do not need to switch the direction of the inequality, and it's going to stay like that. And then 9 times 4/3, I'll make that a 1 and that a 3. Becomes 12. So here's my inequality that I'm left with. X is less than or equal to 12. Okay? If I were to put that on a number line, I'm just going to put some numbers above and below that. So let's go 10, 11, 12, 13, 14. It doesn't matter where you put it on the number line. X is less than or equal to 12. Notice this is underlined underneath here. Because it's underlined, I am going to enclose my circle. This is how I remember it. It takes more ink to make this symbol than it does to make this symbol. So when I go to make my circles, it takes more ink to color it in than it does to not, obviously, and that's how I remember it. Okay? So my magic number is 12 here. This is telling me I want all the numbers that are smaller than 12. Okay? All the numbers that are smaller than 12. Well, the numbers that are smaller than 12 are to the left of 12. So I would shade this direction in this case because 11, 10, 11, 9, 8, all those numbers are smaller than 12. If you have not figured out yet, as long as you have this solved so that your x is on the left-hand side of this inequality, you will always shade the direction the arrow is pointing. The arrow points to the left, I will shade to the left. However, you need to be careful because if I had that, okay, then I am not shading the direction the arrow is pointing. That little trick only works when your x is on the left, okay, when your x is on the left. All right, so here we go. In solution set, again, funky bracket, x, such that, every single time. And then all you need to do is copy that, such that x is less than or equal to 12. Okay? Solution set, again, you're always working from left to right. So you want to think about where you start shading. Well, I actually start shading, I don't know where, way the heck down here, because remember the shading goes on forever and ever and ever and ever and ever. I'm going to shade all the way until I go over here. So from the left, I'm shading from negative infinity. Again, negative infinity, whenever you use infinity, you're always going to enclose it with a parentheses and then a comma. So I'm shading from all the way down here, which is negative infinity, and I keep moving to the right, 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 until I get right here at 12, and I can include exactly 12 in this case because it's underlined. So because I can include exactly 12, I will close that with a bracket. Okay, so if it's underlined right here, it will be a bracket over here. Okay? All right, a couple more here. I always like to solve these so that I have my x's on the left side so that I can use the little trick of the arrow pointing. Okay? So I am going to subtract 5x, which I know makes my x's be negative, but that's okay. And then I have negative 2x minus 18 is greater than or equal to 21. I will add 18. And by the way, up above I subtracted 5x. I did not multiply or divide by a negative. I only subtracted, so I do not need to switch the direction of the inequality. Here I am adding, so again, I do not need to switch the direction of the inequality. And so when I do this, 21 plus 18 is 39. Do not need to switch the direction of the inequality again. Divide by negative 2. Ooh, did I do that right? Nope, I did not. So make sure you catch yourself too. I divided by a negative, and because I divided by a negative, I need to switch the direction of the inequality sign. So my inequality sign needs to be pointed to the left now instead of to the right. And you can leave that as negative 39 halves if you want. Or since you're going to put it on a number line, it might be easier to think about it in decimal form, which is negative 19.5. Okay, so there's my inequality now. X is less than or equal to negative 19.5. So when I put this on a number line, I'm just going to go, let's see, let's go negative 17, negative 16, negative 18, negative 19. I should have gone this the other way. Negative 20. I'll put another one down here. Negative 21. Okay. All right. And I actually should not have those colored in. Sorry. All right. So my inequality is that x is less than or equal to negative 19.5. Negative 19.5 is right here. It's less than or equal to, so because it's less than or equal to, and that's underlined up there, I'm going to just write this down here. Again, because this is underlined, I will color my circle in. I want all the numbers that are less than or equal to or smaller than or equal to negative 19.5. So the ones that are smaller than or equal to negative 19.5 would be down this direction. Again, my x is on the left, so I can point to the left. Okay? In set notation, set of all x, such that, and then just copy this for me. X is less than or equal to, sorry, negative 19.5. Funky bracket. Over here, again, as you move left to right, so where do you start shading? Over here, you have shading, 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 all the way from this point, and we don't really know what that point is because it's negative infinity. So negative infinity, again, always has a parentheses and not a bracket, all the way up until I hit that spot right there, which we know is negative 19.5. And I can include exactly that spot because it is underlined. So because it is underlined, I will have a bracket. If it was not underlined right there, you of course would have a parentheses. All right. Then this one, I am not going to take the time to do all of the, well, maybe I will. Okay, here we go. You want to solve this, and sometimes people have a hard time solving this. But the first thing you want to do is get rid of this 8 right here. I'm going to multiply both sides by positive 8 because it's divided by 8 right now. Again, I'm multiplying by a positive, so I do not need to switch the direction of the inequality. So I'll have 2x plus 4 is greater than or equal to 64. Subtract 4. Again, I'm subtracting. I only switch the direction when I multiply or divide by a negative. Divide by 2. Because I'm dividing by a positive, I do not need to switch the direction of the inequality. So that's what it looks like. Okay. When I would put this on a number line, let's say I'll have 30, 31, 32, 29, 28. Okay, so x is greater than or equal to 30. So I'll make a circle at 30. I will color it in because it's underlined. And greater than or equal to, all the numbers that are greater than 30 would be to the right of 30. Okay, so in set notation, funky bracket, set of all x, such that, and then just copy. X is greater than or equal to 30. In interval notation, you're going to tell me where you shade. So again, I want you to tell me where you're shaded moving left to right. So as I move left to right, let's say this was a pen and I'm moving left to right, not shaded, not shaded, not shaded, not shaded. Oop, I start being shaded right here at exactly 30, and it will be a bracket because it's colored in. If it was not colored in, it would be a parentheses, and then I've shaded everything to the right, all the way to the right, as far as I can go. And as far as I can go would be positive infinity, and you always close that with a parentheses. All right, then, kind of a weird case here that we need to look at. I need to distribute this negative 2 through, so I'll have 3x minus 16x plus 18 is greater than, and I'm still on one side of the inequality symbol. So I know some people think I multiplied by a negative right here, but you didn't do it across the inequality symbol, so don't switch the direction of the inequality right now, okay? Then right here, 3, remember there's this imaginary 1 right there, so you need to make sure you distribute that negative through. So when I distribute that negative through, then I have negative 2x minus 7, okay? Now, combine your like terms on each side, so I can combine these two and make negative 13x plus 18 is greater than. And on this side, I can have negative 2x and then combine the 3 and the negative 7 to make negative 4. Add 2x. So I'll have negative 11x plus 18 is greater than negative 4. Subtract 18. Again, I'm subtracting, so I do not need to multiply or divide by, or switch the direction of the inequality because I'm not multiplying or dividing by a negative. Negative 11x is greater than negative 22. Now divide by a negative 11, and because I divided by a negative, I need to switch that direction, and it will become this. Okay? So, in set notation, it will look like that. And in interval notation, it helps to have a number line first. So let's say this is 2, 3, 4, 1, 0. Open circle at 2 because it is not underlined. And the arrow is pointing to the left, so I'm going to shade to the left. Again, that only works as long as your x values are on your left-hand side. Mine are. The other way to think about it is you want all the numbers that are smaller than 2. The numbers that are smaller than 2 are to the left of 2. So, from left to right, I'm shading all the way from negative infinity up to 2, not including exactly 2, so I have a parentheses. And one more here. I distribute this 8 through. So I have 8x plus 16. Distribute the negative 3 through. Negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12. I know you're multiplying, but you did not multiply or divide across the inequality symbol. So don't switch the direction of the inequality. Okay, is less than. 5 times x is 5x. 5 times negative 7 is negative 35. And then plus 8. Combine your like terms. So when I combine my like terms here, 8x minus 3x would be 5x. And then 16 plus 12 would be 28 is less than 5x. And then negative 35 plus 8 is negative 27. Want to get everything to one side here, so I subtract 5x. Some of you are realizing what's happening here. My x's are gone, and I have this left. Okay? So, when your x's are gone, I have no more x's left. You have two choices. Okay? Your two choices when your x's are gone. If this is a true statement, the question is this: is 28 less than negative 27? Is that a true statement? Is 28 smaller than negative 27? And no, it is not. Okay? So, because this is not a true statement, x's are gone and not a true statement. So the answer is actually no solution. There is not a solution here. There is not a number I can graph and anything to shade. Your answer simply is no solution. Okay? However, different problem now. Let's say I did all of that work, pretend like none of that happened, and I got something like this. All my x's were gone, and I got 5 is less than 7. Okay? So here we go. All x's are gone, but a true statement. So your answer here is actually all real numbers. Okay, that means if you were to shade on a number line, you would shade every single spot there is. Okay? And I would write this stuff down, by the way, you guys. All x's are gone, but it's a true statement, so your answer is all real numbers. Here's how you write all real numbers. In set notation. Okay? In set notation, it looks like this. Set of all x such that x, and now this is a funky E, and it means it's an element in. Okay? So it's kind of like a C with an E through it, with a line through it. An element in, and then you make 2 lines for an R. That means x is an element in, and that R, that funky R, means all real numbers. Okay? In interval notation, you would shade everywhere on that number line, so you would just tell me you would go from negative infinity to positive infinity, like that.